Hello, everyone, and welcome to another episode of Containers from the Couch. Today, we've got an exciting topic for you. We're going to be talking about generative AI and how you can work with generative AI, especially Stable Diffusion, running on Amazon EKS. I've got two experts in the space here with me today. I'd like to start by first introducing them. Rama, tell us a little bit about yourself and what you do at AWS and what we're going to be talking about today.
Sure, Sai. Hi, I'm Rama Ponuswamy. I'm a worldwide go-to-market specialist focused on go-to-market for AI ML workloads landing up on EKS.
Awesome. Thank you and welcome. Apurva, let's go to you next.
Hey everyone, Apurva Kulkarni here. I'm a specialist SA for containers at AWS. I help customers build awesome things and interesting things on top of AWS container services, including Amazon EKS.
Awesome. Okay, so today we've got a demo-filled episode. We're going to be showing how Stable Diffusion actually works on Amazon EKS, running on Amazon EKS. For the folks that are watching and don't know what Stable Diffusion is, it allows you to generate images using a text prompt. So it's kind of like a text-to-image generator. And it's part of some of the kind of revolution of AI tools we've been seeing over the last few months. I'm pretty excited about this one. And a lot of you might be wondering, how does this have anything to do with containers and Kubernetes? You know, of course, on Containers from the Couch, we talk about tech that can run as containers. We talk about scalable workloads, batch processing workloads, a lot of different things. But believe it or not, AI/ML has a very tight marriage and convergence with running on containers and Kubernetes. We'll explain all of that and more in a few minutes. But Rama, I've got kind of my first question for you here today. What is generative AI in your own words?
Yep. So, we all know AI/ML, right? It has existed for at least more than a decade now. So that's nothing new there. But generative AI is really what is putting it on the map and letting us all talk about it. And I like to say it's the hardest thing since sliced bread. And what made generative AI possible were three key innovations that happened over the last decade, I would say. And it started with big data, right? Massive proliferation of data, how businesses started collecting a lot of data, and technologies came out with more efficient ways of storing that data, processing that data at massive scale as well. Right. With that, businesses started to think about how do we make efficient use of this data? How do we ensure that we are using this data to drive intelligent business decisions that let them serve the customers in a better way? So that combined with the second innovation, which is the cloud computing innovations, which made availability of scalable compute at massive scale and made it accessible to anybody. Right, it went from having to build data centers, having to think about capacity needed at a early stage, to just being able to provision the required amount of capacity within minutes. Right, and the latest innovation that has helped generative AI come up to the fore is the machine learning innovations that have happened, which have made it possible for these AI machine learning models to hold a lot of parameters at massive scale, making them a lot more intelligent in being able to process requests and respond to those requests in an intelligent manner. So the conformance of all of these three different innovations has made generative AI possible, and that's what has served as a tipping point for AI and machine learning in general as well. So just to set up the potential that generative AI has, we have all been hearing a lot about generative AI. I thought it'd be good to put a number to it. And again, there are varying numbers, but I picked one from the Bloomberg report, which states that there is around $1.3 trillion of opportunity that is waiting to be driven by generative AI in the near future itself. Right. So in terms of use cases, there's a wide variety of use cases and applicability for generative AI models in general, starting from improving your internal business processes and operations, as well as enabling your developer productivity by using conversational search or by using code generation tools, code companions like Code Whisperer, so on and so forth, as well as in terms of how do you improve marketing using creativity and content creation through generative AI models, uh, enabling you to put out marketing content much faster and more efficiently. And of course, last but not the least, it's about enhancing customer experience via chatbots and virtual assistants and AI powered contact centers as well.
Excellent. And we know that there's a lot of different ways that AI and ML is being used by companies, corporations today. A lot of what we're seeing is the kind of final product. These models have been trained, and now we get to leverage them. Whether we're using, the chat models that are available, the Stable Diffusion, but to actually create those models takes a lot of compute power and a lot of engineering behind that work. Now, Apurva, I want to pass it to you to first explain a little bit about Stable Diffusion, and maybe we can even see a demo. But before we do that, I just want to share, right before we jumped on this call, I actually asked a very popular chat model, generative AI model. I asked it to explain to me how generative AI works, particularly things like Stable Diffusion, text to image kind of generators. And what it told me was very interesting. And if I can summarize that here, watching you do all this. So it knows that you can take these pieces and build houses from them. But when we ask this box to learn about the homes we've created, it only takes a few critical pieces. It doesn't take all of the Lego pieces, and it takes those few critical pieces and puts them in a special magical box. Now, when we tell this magical Lego machine to build us another house, it's going to be able to do that without having to have all of the Lego pieces. It'll only need the critical pieces that it has in the box. Now imagine we take that box and we shake it up a bit. Maybe we change a piece or two in there and we ask it to build a house. Now that house is not going to be exactly the one that we built, but it's going to be pretty close. And what we're doing there is fine tuning it. Now imagine we had a magical talking parrot that can talk to this box and tell it exactly how to customize the house we build. We want a pool or a chimney or whatever it might be. Well, that's where we get into the kind of fine tuning of the model, the text to tokenizer type algorithms, and a few other complicated bits that I'm glossing over. But that's essentially the idea. Now, if we take this example and we go back to the compute here, essentially the Lego pieces representing pixels in an image, the magical box being a latent space, and the kind of fact that this model is only taking a few of the Lego pieces and not all of them shows that it's working with a subset of the original image, right? In the latent space, it has just a few of the Lego pieces it's working with. And that's compression. And that's because if it had to work with all of the pixels, well, it would need an extensive amount of computing power. But what about when you need that kind of computing? What if you need high resolution generation? What if you need to train models across massive data sets? That's where the cloud computing and EKS comes in. I thought that was a really cool way to explain how Stable Diffusion generative AI works. So I wanted to share that with you. But here we go. Apurva, I want to pass it to you here to talk a little bit about the demo you're going to be showing us today and tell us about Stable Diffusion.
Yeah, no, that was an awesome explanation. Thanks. It actually made me understand a few things too. That was pretty cool. Uh, so yeah, if you could share my screen real quick. So what I have this is welcome to my awesome new startup. So it's called Dog Booth. So the idea behind Dog Booth is that you can upload a few pictures of your dog, and with a prompt such as a photo of VDog being your dog, uh, in a on a beach or on the moon or in a pool, you're able to recreate pictures of your dog in different scenarios, so that you don't have to go through the effort of actually taking the pictures. Now, if you're a photographer, you might want to do that, but in general, like, think about it from if you're a retailer, like selling backpacks, for example, and you want to recreate the pictures of your backpack in different uh, scenario. If you go to Stable Diffusion and you say give me an image of a backpack in the Swiss Alps, for example. It'll give you an image. It would be a beautiful image. Now you go and give it another prompt saying, give me a picture of the backpack on Mount Everest. It would be a different backpack. It won't be the same backpack. And so there's a paper that was written by folks at Google Research called Dream Booth. And it's basically it talks about how do you fine tune a text to image diffusion model, such as stable diffusion. It doesn't have to be stable diffusion. There are other latent diffusion models out there. And you'd fine tune a diffusion model for that subject driven diffusion generation, right? So in the examples, they show this as the dog, but they also talk about like training picture, like using backpacks or dresses, any object that you want to be able to recreate in different scenarios. This is how you would kind of go about doing that. So this is a paper that they wrote. I think there's a link I shared with you, Sai, if you could drop the link. It's a really cool read, even if you're not, I mean, I'm not a machine learning expert by any means, but I definitely, by just reading the abstract and like trying to understand, what does it mean to actually adopt and personalize stable diffusion so I can use it in for my business application. This paper, reading through that paper, made a lot of sense. And so when I went about like kind of figuring out what do I need to demo, this is kind of what I did. Was like I built a simple UI. It's like my awesome startup called Dog Booth. And by the way, like if you're interested, I built this UI using a project called Streamlit, Python-based project to kind of build UIs really quick. I knew nothing about Streamlit until yesterday, and I was able to kind of put this together in like 1 hour. Uh, so really cool way to do it. So now I've got a place where I can create a prompt, and send a prompt to my uh, hosting environment. So photo of a wee dog on a beach. So let me kind of fire that off. And so what it's going to do is going to send this prompt to my backend infrastructure, which consists of and we'll talk about that a bit later. But it basically, I'm hosting an inference for a trained or tuned stable diffusion model using the Dream Boot technique. And so that model is already there, and it takes a couple of seconds for this image to come back. Uh, but essentially, when we see the response, we're gonna see a photo of this dog in on a beach, hopefully. And so while that's doing that, like, I'm going back to kind of Dream Booth and like how you would go about doing that. Uh, you can do it on Kubernetes, and you would need a few things that uh, largely open source components that I've used in this kind of project. I'll dive deeper into those when we come back after the presentation. But yeah, here we go. So this is the photo of this dog on a beach. Uh, Now you will notice like that there's a few misfiguring on the face, and like the beach is not really that greatly visible. Like this is the part where it goes into like experimentation and how do you go about getting really accurate with the performance of the model. And we'll talk about like what are the things that go into making this model better performant a bit later. But yeah, that's basically like the premise of what we want to talk about. Like how do you take a large model such as stable diffusion and adapt it and personalize it for your own needs using technique like Dream Booth.
Okay, that's really cool to me, because what we've done is we've taken this model that's already been trained with so many other pieces of data on the beach and dogs and that kind of thing. But
Yep.
what you're able to do is have your specific dog,
Yeah.
your pet. In this case, it's using the Dream Booth. It's like a baby. I think it's a corgi. I'm not
Yeah, it's kind of a corgi. Yeah.
yeah. And so that's
Yeah.
really cool, because you're not saying a corgi, you're saying a V dog, which I
Yeah.
guess it's the designator for the custom dog that you've
Correct.
trained
So
this
that's the
stable diffusion with.
identifier that I use. The V dog is the identifier I use to kind of when I tune the model. That's the identifier that associates. So my training, like when I train the model, it's this particular dog, and that's the identifier I use to associate this dog with that identifier, right?
Yeah.
And now look at this, like it's the model is not that great because, and we'll get into the reasons of that. And this is where you kind of have to like get really, why do you need to experiment, like how do you go about doing the experimentation, and we'll talk about that. But yeah.
I actually, this is a common phenomenon with AI, the kind of double head syndrome. And this happens. I was doing some research earlier. This happens when the feed images you're using to train the model are too high a resolution. So when it
Right.
does the decompression, it's unable to retain important facts about the original photo.
Correct.
So
Absolutely.
point
Yeah,
being
but
here,
we can see like it's trying to recreate the same dog. Like it's not a random dog that it pulled out of. Like it's not a German Shepherd or something. It's that exact dog, and so that's where it's trying to like personalize. We are trying to personalize this model, and now we need to get better at making this model better performant. But that's the
yeah.
idea.
But I can imagine, there's the possibilities for this are endless. I mean, for people out there that are trying to sell their product, maybe they have an e-commerce brand, maybe they're trying to get some nice stock images for their product on Amazon or something like that.
Yep.
They could take some very simple stock images on their phone, feed it into the algorithm, and say, okay, let's say I'm selling a teapot. Show a picture of my teapot being poured on a beach in Asia or something. And you could have that photo get generated for you without having to fly out there
Right.
yourself. So the possibilities definitely seem endless here, at least in that one use case, but I can imagine in other use cases as well. Now, Rama, I'd like to kind of go back to you here. I know, by the way, folks that are watching, we're going to have more in-depth kind of a view into how that demo that we just saw worked. Apurva is going to show us some of the code behind the scenes, how the fine tuning worked. So be sure to stick around for that. But first, I kind of want to tie this back into containers and Kubernetes, because that app that Apurva was showing us was running on AWS. It was powered by a Kubernetes cluster. So I think it's going to be critical for us to understand, where did the two actually link up? So that's my first question to you, Rama. Before we even get into Kubernetes, really, what role do containers, containers in the sense of application containers being able to package applications, what role do they play when working with generative AI, AI/ML, and processes like Stable Diffusion?
Yeah, absolutely. And then I see already a question comes up like, why use EKS for this, or as opposed to other options that we might have, right? And this like a whole spectrum of options available for you when you try to do this and solve some of the challenges that comes with developing these models. But when it comes to containers, the reason that containers came as a solution were to solve particular challenges, right? That comes with any application development, is how do you make sure that you package all of your dependencies for your application? How do you make sure that you are able to consistently move them across different environments and different lanes that you might have within your enterprises? And how do you ensure that you're able to enable your customers or your developers, in the sense, to accelerate their development and offload them from having to think about things that they don't need to, about infrastructure provisioning and maintaining consistency across different environments. And those are the exact reasons why containers are best fit for machine learning, because all of those problems still apply to machine learning, right? Especially with machine learning applications, you need to package them with a lot of dependencies, libraries, depending on the framework that you choose to use. And it's also about toolkits that you need to use when it comes to enabling your model to access the GPU layer in order for it to be trained and efficiently inference on it. So that's exactly what containers serve, the purpose that containers serve for machine learning as well. With that, you get to efficiently package all of those dependencies and toolkits and your training code on top of that, and it makes it easier for you to maintain configurations across different environments, which means that you get to easily port your application, makes it lightweight, and makes it easy to scale, because scaling is going to be a key challenge when it comes to being able to develop efficient machine learning models, because all of them require hyperscale of resources. And of course, it also ensures that you are being consistent across your different environments without having to worry too much whether you've left out a particular dependency within your model, and having to worry about all of that.
We've got another question here, Rama, from Sample User on YouTube. Now, Sample User is asking, can we use local LLM models? And I think, just to kind of extend on this question, I think the idea here is, do you have to work with proprietary models here, or does this ecosystem allow you to create and work with custom models as well?
That's the key strength of it, right? Like you can develop your own models, and you can also leverage existing models. It fits all of your needs, right? It's more about flexibility and control that you get with Kubernetes and the open source ecosystem, which is exactly what I was going to talk about next. Is, you've decided to use containers, then why use Kubernetes, right? There are options that you can do container orchestration. Kubernetes, because it provides you a lot of these orchestration capabilities out of the box, right? For example, auto scaling, right? You can easily configure the scale that your containers would need, and make it respond to requests that are coming in, and can scale automatically and scale down back as well whenever the requests die down. Another key aspect is resiliency, right? It's inbuilt with Kubernetes. The Kubernetes controllers ensure that the desired state that you have configured always remains so. The expected state and the actual state always remain in tandem, and the controllers take care of it automatically for you without you having to worry about anything. So those are some of the capabilities that enable Kubernetes from an orchestration standpoint, enabling you to achieve scale with your container-based machine learning uh,
Yeah.
models as well.
And one thing that I want to call out here as well, I think we kind of glossed over the fact that there's this open source ecosystem, but I've got to call out that this is something that's really powerful for our users that are working with Kubernetes here. There are folks in the community that have pulled together all of the different open source tools that can support custom AI ML models. Tell us a little bit, Rama, about at least standardizing on a set of solutions, or how it can be a little bit easier to get them up and running because we're working with the community in this space.
Definitely. And another point I want to note is that most of the generative AI models that you see out there, even basic models that are popular right now, have been trained on Kubernetes, right? Most of the models are using Kubernetes for them to train, exactly because of these reasons. So there's multiple open source solutions available out there that address specific functionality when it comes to orchestrating the machine learning workflow that is needed for you to achieve the scale as well as efficient models that are coming out of it. As well as in terms of standardization, right? We see a lot of customers not just treat Kubernetes as a container management solution, but they are standardizing on the Kubernetes API as the standard interface for everything that their developers do, as well as to standardize their entire DevOps flow when it comes to not just machine learning applications, but any application development that is happening is being standardized on the Kubernetes API. And of course, another key advantage is Kubernetes being an open source solution. You get that consistency irrespective of where you're deploying Kubernetes on. It could be in multiple environments, multiple providers, and you get to have that standard interface that you can work with across different environments without having to develop different operational procedures and processes for your different environments.
Absolutely. And quick side note here, folks that are watching, if you have any questions while we have our experts online, don't hesitate. We're here to help you. So I see a few of you folks tuning in here. If you have any questions, any comments, feel free to drop them in chat. I'll make sure they get addressed. Thank you. Go ahead, Rama.
Yeah, so those are the key reasons why we see customers using Kubernetes, as well as most of these open source models and GenAI models that are coming up are able to use Kubernetes and depend on those out of the box capabilities that Kubernetes provide to solve a lot of these foundational problems and challenges that they face.
Excellent. Now, one of the things that I know we talked about the open source ecosystem here, how a lot of the models that we see that have been trained out there today are built on similar compute stacks. Whether we look at things like ChatGPT or Stable Diffusion, all of these are models that have already been trained. And for that training, you do need a significant amount of compute power. Now, once those models have been trained, of course, to run them takes less compute power, but really that's the idea here. That's the phase of the development we're talking about. You're using Kubernetes and the vast amount of compute available through cloud computing to train and build these types of models, large language models. Now, that being said, kind of the next thing I want to ask: what are the use cases that you can use Kubernetes and AI ML together to accomplish?
Yeah, so I just wanted to touch upon the different challenges that you might face, right, when it comes to machine learning and generative AI specifically. And Sai and Apurva, both of you sort of touched upon these different stages that machine learning model sort of goes through, right? It's usually starts with model development, where that's where the foundation models come in. With the generative AI and large language models, these are models that are trained on generic set of workloads, right? So they are meant to meet a wide variety of use cases without you being having to create these models by yourself. That's a key difference between generative AI and, as opposed to the traditional machine learning models that we used to have, wherein each new use case needed a model that needed to be developed from the ground up. Whereas with generative AI and these large language models, or foundation models as we call them, these models can hold billions of parameters and weights, and they can be trained on a generic set of workloads, allowing them to acquire that intelligence that they need to solve a multiple variety of use cases. So which means you need hyperscale to create these foundation models, right? If you're trying to come up with a product that is built on a proprietary foundation model, you need to come up with a way to scale the different how do you develop that foundation model for training as well as for inference needs as well. So the foundation models are some things that you can leverage, and as I said, these are generic built models, right? So what you saw Apurva do earlier was like, how do you fine tune those models, right? In order, and if you don't fine tune them, you would see a lot of issues that we saw earlier with, dog with two faces, people with 20 fingers, 35 fingers, whatever, right? So in order for these foundation models to work efficiently for a given specific use case, you need to fine tune them. So when you're trying to fine tune them, again, it is resource intensive to fine tune them as well. But considerations that come into the picture are, how do I ensure I'm securely moving the data to fine tune that model, because usually these will be proprietary data that you're using to fine tune it to fit it to your own needs. And how do I ensure I'm protecting the intellectual property of my sort of data, that and the model that I've trained using my own data as well. And when it comes to inference, it's the last stage where the model is actually receiving requests and processing it and responding it back. And the considerations during that phase are, how do I ensure my customer is getting quick responses, how do I ensure it's getting high quality responses, and how do I make sure I do both of this in an optimal cost, right? So it boils down to ensuring low latency, high performance of your models, and ensuring you're making the trade-off decisions to ensure that you are not driving your cost way too up. But of course, we are seeing this as different stages. But when it comes to a single machine learning model or a product, you really need to do all of this, right? You need to orchestrate all of this for a machine learning model to go from inception to development to actually serve inference at the end of the day. So orchestrating all of these different stages could become quite complex when it comes to machine learning models as such.
Excellent. And sorry about that, folks. I was having some technical difficulties. Hopefully, I'm back and clear. But Brahma, I think that's a helpful overview. One of the things we talked about earlier was kind of standardization, working in the open source ecosystem. There's benefits associated with this, but then there's also kind of information overload. How can we kind of help our users wade through all of the different tools out there that support using AI ML on Kubernetes?
Yeah, I wanted to talk a bit about how EKS and AWS in general can help these customers at a generic level when it comes to
Mhm.
machine learning and especially generative AI workloads, right? It really starts from the infrastructure layer. When you're using EKS on AWS, you get a choice of different GPUs that you can use, ranging from purpose built uh, processors that AWS has developed, AWS Inferentia and AWS Trainium, or you could use leverage NVIDIA GPUs and a variety of Amazon EC2 instance types to have cost effectiveness. Like you can use pod instances, you can leverage on-demand instances, so on and so forth. Right, all of this gives you flexibility. In the processes that you want to use to make trade-off, like I want more efficiency, I'm not bothered about the cost, you can do that. I want optimal efficiency but want to drive down cost. That's where Trainium and Inferentia sort of help you achieve that scale as well. But After, on top of the infrastructure layer, what you guessed is in terms of model development, right? How do you enable your developers to quickly develop and experiment on a model? As we saw earlier, right, it needs a lot of experimentation for a developer to get the model right. How do you make sure that your developers are able to quickly experiment, iterate over the model versions, and come up with something that can be pushed to production? And that's where containers come in, as we spoke about earlier, right? It makes it easily portable. It makes it easy for developers to bring up environments, just run it on a container, bring it up, experiment on it, and then scale it once the developer thinks the model is ready to go. So it makes portability easier. It makes consistency almost built in with containers, and it helps you achieve scale, right? And that's where EKS also comes in, as we mentioned earlier or talked about earlier. Apart from auto scaling and resiliency that is built in, it helps you easily orchestrate training and inference by reducing failures as well. But another thing that I do want to mention, I touched upon this a little bit earlier, where we're seeing customers standardize on Kubernetes, right? What we're seeing with EKS is customers are actually building internal development platforms that are using EKS. So when it comes to machine learning as well, the innovations that are happening in generative AI are only solving the model efficiency layer of it, right? You still have to solve a lot of functionality, such as how do you efficiently do identity and access management? How do you make sure you're able to provide a multi-tenant environment wherein organizations and teams across your enterprise are able to effectively share and make use of the scarce resources that are available? How do you make sure you're monitoring? How do you make sure you're doing logging at scale? How do you ensure your enterprise governance are being met? How do you ensure security is being maintained across all of these workloads, and so on and so forth, right? So all of these questions still remain. You still need to solve it even for your machine learning workloads, and that's where these foundational EKS platforms that our customers are building come into the picture, because that platform already solves all of these questions for you, right? So you're not having to reinvent the wheel when it comes to just for your machine learning workloads, which lets you quickly adapt your machine learning models, as well as scale it much faster than if you were to develop it from the ground up. And so, because you're building just on top of the existing foundation, which solves all of the challenges for you, you're left to just focus on relevant questions when it comes to just orchestrating your machine learning model workflow. Right? And for that, we have a wide variety of open source ecosystem tools that are available that specifically focus on solving these workflow challenges, like what we saw earlier, like how do you efficiently do model experimentation, training, fine tuning, as well as doing inference for you, right? And this is just a snapshot of the different solutions available out there for you to do that, in terms of the open source ecosystem. And another meta point that I want to mention on the earlier slide is what this gives you is control and flexibility across all layers of your ML stack, right? So you get to make trade-off decision at each layer of your machine learning model, as well as it lets you drive cost efficiency and scale much faster than if you were to build things using your own models, right? And in terms of talking about open source ecosystem tools, you get to leverage these open source innovations without any additional cost for you, right? And you get to pick and choose the right tools to address the right challenges without having to use a one size fits all sort of a solution where you're having to make a lot more customizations than that is needed, right? So in terms of the tools available, it starts from the model frameworks, the wide variety of frameworks that are available that lets your developers quickly get started and leverage existing libraries to build functionality that they would need and experiment much quicker as well. Like Jupyter Hub, for example, is a very widely used tool for model experimentation. And when it comes to model development and training and actually orchestrating the entire workflow, there are multiple tools like Kubeflow, MLflow, Ray, etc., that are available as well. And in terms of serving, as I mentioned, AWS Neuron SDK is available if you're looking to leverage training and inference here, or if you're leveraging NVIDIA GPUs, there is wide variety of ecosystem from that NVIDIA provides on the software layer as well, in order to efficiently use their GPUs to enable efficient model creation as well.
Yeah, actually, I'm glad you brought that up, Rama. We actually have an upcoming session with speakers from NVIDIA, talking about NeMo. They're going to be on Containers from the Couch. I believe in October. You can find it on Containers from the Couch, our channel on YouTube, and make sure you get notified for that. That should be an interesting session. But coming back to this, Rama, I love the fact that you show us this graphic here. If there's one thing that our viewers here on Containers from the Couch tell us that they enjoy seeing, it's demos and kind of some of the architectural diagrams to go with those. So while this is kind of a view at all of the things in the ecosystem that, or maybe not all, but a lot of the things in the ecosystem that you can use on EKS, let's dive into Dog Booth, the demo that we saw earlier, and the actual architecture diagram that Apurva used to build that specific demo app. Apurva, you think you're ready to go through that for us?
Yeah, let's do it.
Let's do it.
All right. So this is like think of this like an infrastructure diagram for how I went about building the stack I needed to run like Dog Booth, both the web app as well as the inference endpoint for it, and how I went about kind of iterating on the model and building that fine-tuned model. So actually, let's kind of go from like a data science perspective first, right? So as a data scientist, I want to be able to one of my primary tools is going to be a Jupyter notebook, right? This is just extensively used across the scientific community, both in education and commercial applications. And so it provides me with a way to kind of run my Python, being the most popular kind of language with this domain. It allows me to run like Python scripts, Python programs, etc. Right? So I have provisioned a Jupyter notebook using Jupyter Hub. Jupyter Hub is open source project. Again, they provide a way for you to be able to provision Jupyter notebooks. You can provision n number of Jupyter notebooks, and these notebooks can run as pods on Kubernetes clusters. Because I'm going to be training a stable diffusion model, I need my notebook container to be able to run on a GPU-based instance, so that I can kind of take advantage of that GPU to tune the model. And so by specifying the resource requirement in the notebook specification, my notebook is then provisioned on that GPU node that I have as a part of the EKS cluster. And so as a data scientist, I jump into the notebook, I will tune my model, run my training scripts, etc. And once I'm happy with the model that I've built, I basically, in this case, I'm pushing it out to Hugging Face. So I've pulled the model down from Hugging Face and I'm pushing it up back to Hugging Face. Hugging Face in this scenario is acting like a model registry for me, right? And you could use another option here, such as MLflow or something else that you're using within your enterprise. I'm just using Hugging Face because it's the most easiest integration that I know of. And there might be others out there. So once I've kind of pushed the model back, the tune model, so the Dog Booth model, to Hugging Face, at that point, my model is kind of ready to be deployed into production. And in order to do that deployment, I'm taking advantage of Ray. If you're not familiar with Ray, I encourage you to take a look at it. But it provides me for it to so basically you run what's called as a Ray cluster. And a Ray cluster consists of head nodes and several worker nodes, and these can be auto scaled. And it provides me a way to run distributed Python programs on top of Kubernetes cluster. And it could be any distributed application, including machine learning models. And so with Ray, I'm able to kind of the integration that Ray provides, I'm able to host an inference endpoint such that I can pull that model down from Hugging Face that I've previously built and serve it using a custom resource, again called as Ray Serve. And Ray Serve is essentially how you would go about serving a Python application, including a machine learning application. It's obviously, with Kubernetes, you need some kind of an ingress. So again, like there's a network load balancer sitting on top of it that kind of routes incoming requests to Ray Serve, and then it's served by that Ray cluster.
So Apurva, we've got a couple of questions here. I think we're at a decently good stopping point here. I feel like we've gone through most of the components here. The first question is from a LinkedIn user here. Now, is this OSS ecosystem supported by AWS? For example, will AWS help support a customer with using tools like TensorFlow, PyTorch, Jupyter? since they're not AWS, services or products, but rather free OSS projects?
So no, I mean these are open source community based projects. We don't really have like capital S support for it, right? But we do have a lot of experts in in these frameworks, and kind of if you need specific help, while this may not be like official support channels, you can still ask for help, and if we can kind of provide you some guidance in that area. We definitely have some experts that can help you with some of that. So yeah, in that scenario, like reach out to your account teams and kind of help try to get some help, and we can kind of help you, provide you some guidance and best practices around it. But yeah, not officially supported by AWS. Yeah.
One of the things I like to go back to here is something what we talk about for a security model at AWS, how AWS is responsible for security of the cloud, and a customer is responsible for securing what they're running inside the cloud. Now, very much kind of similar to this example here, AWS is going to help support the infrastructure, the compute, Amazon EKS, the networking constructs here like VPC. A lot of the boxes you see here are supported by AWS because they are the cloud. Now, what you're running in the cloud, where your application workloads come in and that kind of thing, now they're not directly supported by AWS. But I've got to tell you, we've got a number of folks working in these open source communities, and our support staff is just excellent at kind of working through our customers with issues they might have with specific open source projects and workloads like this. So
Yeah.
it kind of goes into it, but without capital S support, kind of like what you said. Anything you want to add there, Apurva, Brahma?
No, but this is where we have the data on EKS project that we'll talk about it a bit later as well. But we provide modules, frameworks, and sample blueprints that you can use or leverage with best practices built in that will let you accelerate your adoption as well. But we'll talk about it towards the end of this session.
Absolutely. And quick filler comment here. We might need a fit check from you, Apurva, but is that a ZSH tool?
Yeah, absolutely. I'm a big fan of ZSH, and this was a good way to support that project. So I usually kind of tend to buy, any merch that I like from like open source projects that I use.
Awesome. I bet your terminal is super customized. I might be, if you're doing a demo in your terminal today, maybe you can give us a run through
Yeah,
of the
yeah, I
different.
like simplicity, so it actually doesn't have a lot of things. It's just very bare bones because I don't like a whole lot of things popping up on my
Fair
terminal.
enough. I respect that, the minimalist approach. I like it.
Yes.
All right, Apurva, let's get back to the demo.
Yes. So like I said, like, just Ray service that there's a network load balancer sitting in front of it. And then like I already spoke about the dog booth app that I built using Streamlit. So the app itself does not need to run on GPU because it's like just a regular app that uses Python framework underneath. So that's sitting on like a regular M5X large node group. Like there's nothing special about it. But that's the one that's making those calls out to the NLP. Now, obviously, like in a real production scenario, like the app could be sitting somewhere else. It could also be built on deployed in Lambda or Fargate or whatever. Like whatever compute you need to kind of you choose to do for hosting your app is up to you. I choose Kubernetes because it's just made sense to me to do it in all one cluster. Just a quick note on some of the add-ons that you see here. I spoke about Jupyter Hub already. KubeRay is basically a way. It's an operator that's provided by the folks at Anyscale and Ray. It allows you to run Ray clusters on Kubernetes. So it provides those custom resources: Ray cluster, Ray service, Ray jobs. And so anytime you create a custom resource for any of these objects, you basically get KubeRay will provision that Ray cluster for you. Load balancer controller, obviously, to kind of be able to manage the life cycle of the network load balancers that I need with the Jupyter Notebook and the Ray cluster. ABS CSI driver, if you're not familiar with it, it helps you provision ABS volumes. The reason I need that is because the experimentation I do with Jupyter Notebooks, Jupyter Hub has this cool feature where it's like it will, if you're not using Notebook for a while and it's idle, in order to save on compute costs, it will turn that notebook off, right? But as a data scientist, I don't want to come back and have to like re-download all the Python like libraries that I've been using for my experimentation. So having it run on EBS makes sense, or you could do it on EFS. Uh, and so it basically have the Jupyter Notebook volume run on that EBS, Jupyter Notebook run on that EBS volume for persistence. And then last but not the least, the NVIDIA device plugin, right? This is where the NVIDIA device plugin allows me to allows a GPU node to basically join the cluster and be recognized as a GPU instance, right? GPU capable instance, because when I want to provision resources that need GPU, the Kubernetes scheduler needs to know where those GPU nodes are and where to schedule those pods. And so NVIDIA device plugin helps me kind of when these nodes come up, it will add some labels to those nodes so that the scheduler knows that those are GPU capable nodes. So it's very critical component of this cluster. Um, yeah, so that's the high level architecture. Next, any questions before I kind of move on?
No, I think there is one question here, but maybe we can get back to that in a few minutes, asking around automation and Terraform. I know Rama
Yeah,
wanted to cover a bit of that as well. But how about your specific architecture here, Purva? Is this
yeah.
Terraform?
Yes, actually it is, and we will be kind of publishing the stack out into the data on EKS repo as well. So feel free to kind of take a look at it when it's available. I think I already have a branch up there if you can find it, but very soon it'll be merged with the main branch. And yeah, this is all Terraformed blueprint essentially at this point. So with a single Terraform apply, you should be able to bring this up relatively quickly.
Excellent. I'll drop a link in the chat. Meanwhile, Apurva, I think we're ready to see the next piece here.
Absolutely. So this is like my experimentation phase as a data scientist, right? So I'm going to be running. First thing I run is like NVIDIA SMI just to make sure that the GPU is indeed available to me, right? So the NVIDIA SMI is a command line tool that NVIDIA provides to kind of take a look at your GPU, look at the different characteristics of the GPU, etc. And then the next set of commands is basically just making sure like I'm set up correctly, my environment is I am pulling the Hugging Face diffusers library. And so the Hugging Face provides a really cool Python library to be for you to be able to work with different kinds of diffusion models and do things like Dream Booth, for example. So they already have a training script that you can use to run Dream Booth on any diffusion model. And there are other examples out there. I kind of encourage you to take a look at the different things that you can do with stable diffusion. For example, in painting, out painting. These are the kind of business kind of applications of dream of stable diffusions, and diffusers provides scripts, helper scripts that help you kind of just run your fine tuning or adaptation for those diffusion models.
So Purva, if I understand right, you don't need to be an AI ML expert understanding
No,
every phase of the model training to be able to get business value out of it. So
right.
it's
I'm
essentially
definitely not an AIML expert. Like I barely understand the surface level of it, and even I was able to like kind of get through it. And obviously, it helps if you know a lot and like diving deeper. And it kind of personally like I would love to dive deep and just understand how to get my model performance really accurate. Uh, but this is the part where it's like kind of gets into the whole like data science part of it. Right? You kind of need to dive deep there. But to get started, you don't need to know a whole lot. You can just kind of use these tools that are provided by Hugging Face that help you accelerate your learning.
right. Right. And while Apurva is being humble about his AML experience, he is an absolute pro when it comes to Kubernetes and his operational experience. And kind of what we're seeing here is that even without a specific AI ML experience, you can take these very complex models and insert in the right place the piece that lets you get, business value. Of course, the demo we saw with Dog Booth being able to insert your specific dog into the AI ML model here, the generation model that we have. So
Right.
I'll stop interrupting. Let's keep seeing.
No, all good. So, quick note, right? So, there's like typically like LLM models or diffusion models. These are very large, and when you want to kind of train them on a GPU, unless you have like a really big GPU instance that at your disposal that has like a lot of GPU memory, you are, if you're just playing around with it and experimenting with it, you may have to do optimizations to make the model and all the different tensors fit in your GPU, right? So in this case, I have like one GPU with 24 GB GPU memory. And so there are optimizations that you can do, and they're popular in the community. But I just wanted to quickly call that out. Like, the steps that you see here, a lot of them are basically done to kind of do those optimizations so that my model and the entire like training loop can fit inside that 124 GB GPU that I have.
So
And so,
sorry, I want to interrupt you again. Just a quick question. So a
yeah,
24 gigabyte GPU. Now, if you look at consumer grade GPUs right now, a 4090, the top of the line GPU, has 24 gigabytes of video memory. Um, okay, so that's a lot. That's a beefy GPU. Now, if you wanted to run these models against more, let's say 128, 200, a terabyte of memory, are you able to do that? Can these models handle that amount of GPU and then use it effectively?
yeah, so you can use like underlying Python based frameworks to kind of do the distributed training of these. So there's and including CUDA is the library that NVIDIA provides to basically use it's a driver for their GPUs. And so if you have a lot of GPU at your disposal, you can do distributed training to kind of speed up the training loop. But typically, like when you're starting out, or if you don't have and they're also expensive. So if you want to like do it in a cost efficient way, you may have to do it with a smaller GPU, and like these optimizations help you kind of do that, but at the expense of your model not being accurate and don't have the performance that you need. So that the two-faced dog that we saw is because of the fact that I don't have a big GPU instance where I can kind of be really precise with the training parameters that I provide during the training loop.
Got it. Makes sense.
Yeah. So yeah, again, like a bunch of steps that I'm doing here, just installing some dependencies and optimization libraries that I need. So this is the part where kind of get into like downloading a snapshot of like f- when we speak about Dream Boot typically needs about 3 to 5 images to be able to fine tune. So not a whole lot. So if when you think about like how much data do I need to fine tune, Dream Boot, the paper suggests like you should be able to do it by but between 5 to 8 images are more than enough to be able to fine tune stable diffusion for that Dream Boot purpose. So that's this step is basically downloading a bunch of pictures of the VDog, and this is where I kind of do that. Again, like some environment variables. Another optimization step just to kind of do some optimization for garbage collection, things like that, just so I can like compress everything, fit everything in that one GPU that I have. Signing into the Hugging Face CLI so that I can push the model back out to Hugging Face. And this is where I kick off the training loop. Like I will kick this off, but we are not going to wait around for the training loop to complete because it will take forever to finish. Forever meaning like in the context of like how much time we have left, we don't have enough time to wait. But what this Accelerate is again another library that Hugging Face provides. It helps you kind of automatically insert some boilerplate code that you would need for running this training loop, right? So if you think about things like what is the batch size that I want to be able to tune, or the learning rates, or using the optimizations for the efficient performance of my model, number of training steps, etc., etc. Uh, these are also typically known as hyperparameters. So if you were to kind of do it on your own, you would have to like codify all of this within your training loop. Using Accelerate, you don't have to do that. You just kind of with 5 lines of code within your Python training loop, you Accelerate kind of takes over parameterizing your training loop, and it will just help you run these different kinds of experiments. Now think about running multiple Accelerate scripts in parallel with different hyperparameters for you to be able to optimize your model, right? So you can do parallel experimentation uh, with this kind of a training loop, and this allows you to like have different versions of the model available with different parameters, and you can compare and contrast which is the model that's performing the best, and you pick that out for the production deployment. So with like, I'm not gonna kick it off because, like I said, like it takes a lot of time. But yeah, this is my experimentation phase. Like with what is it, like 10 steps? I'm able to like fine tune the stable diffusion model for Dream Booth. And so when this loop would complete with this push to hub, this model would be pushed out to Hugging Face so that I can pull it back into my inference endpoint. Any questions so far?
We haven't seen any questions coming up in chat, but I've got to say this is really a lot more straightforward than I expected. I think a lot of the value goes to the open source projects here with Jupyter and that kind of thing, paired with the fact that we don't necessarily need to have a 24 gigabyte GPU running next to us, making a lot of heat, taking up all our power. We can on demand spin up an instance in the cloud,
Yeah.
run the models, and then feasibly, based on how efficient we're being.
Yeah, absolutely.
Sure,
There are papers, there are models out there that can fit in an 8 GB GPU as well. So you, depending upon the model you pick and like the parameters and optimizations you do, you can uh, go lower on that value. Yeah.
Excellent, excellent.
Yeah.
We actually did have one question just come in chat. Where is Ray being used in this example?
Yeah. So I'm not using Ray for training. You can, but I'm not using it. But what I'm using Ray is for hosting the model. So once I push the model, the tuned model to Hugging Face, the way I pull it down and host the model for inference is using Ray. And this is the Ray dashboard that you're seeing here. And if we go to Surf, this is basically like, let's see the.
You make that a bit
Sorry.
bigger.
Sorry.
Yep, there we go.
Yeah. So this is my application configuration, and it obviously there's a lot that goes into it that we probably don't have to get into here, but you can see like this is the Hugging Face repo and the model itself. So if you go to like, this is my if you're not familiar with Hugging Face, like a GitHub for models, right? So I have my organization or space call with my unique ID and the model that I pushed out a bit earlier. And so this is the value I provide to that race serve application. And I can even like associate a version with this model as well. So this helps me kind of pull that model down and host it using RayServe. So this is where I am using Ray, and Ray is an excellent option for you to host machine learning models on top of Kubernetes.
Awesome. Awesome. All right. We're coming right up on the end of our time here. So very quickly, I just want to leave one more question, leave this open for either of you. What gets you excited when you think about the future of AI ML technologies and the cloud computing space coming together?
Yeah, we're really in the exploratory phase right now, and like the sort of use cases and the solutions that are coming out are already blowing our minds. And I can only think about what's going to come in a year or so that's going to really fundamentally transform the way we do business, as well as how we do our day-to-day activities. And we're very excited to from AWS to follow along on that journey and support you and help you guide you on all of those generative AI innovations that are yet to come as well.
Apurva, any last comments?
Yeah, I mean, so I'm being a fan of open source technology. Like, I love the innovation that's coming out from the open source community in this space, and just especially like some of the stuff that I've read just on the internet, following some people on Twitter, like how Gen AI and machine learning is being used for good. That's kind of stuff is just exciting. Like if you see, the kinds of stuff they're doing in gene therapy and stuff like that, like those medical innovations that are happening in Gen AI, using Gen AI, like those. I think that we're just seeing the beginning of the possibilities with this, and I'm super excited to see what the open source community can do to kind of make the world a better place.
Absolutely. And I'm going to break our rule here. We're going to go a little bit over time here, but I know we had a question regarding, Terraform and how people can do this at home. And I think it's important for our folks watching to understand how they can do this themselves. Rama, do you want to take a minute and talk about that?
Yeah, so that's why we came out with the Data on EKS project. So what it really means is we put out infrastructure as code templates, as Sapur was explaining. whatever you saw right now will be put out as an infrastructure as code template for you, readily available for you to pick up and use it. You can quickly spin up this entire environment and start to deploy models. But it also has performance benchmark reports that we publish, best practices for you to do this on EKS, as well as deployment examples, sample architectures, so on and so forth. Right, all of this meant to enable you to accelerate your ML adoption on top of EKS. But what we also have is a group of experts within AWS that have expertise on both EKS as well as on AI machine learning models that can help you sort of merge both these worlds and help you accelerate how you deploy your machine learning workloads as well. So feel free to check out our website that Sai had shared, or you can scan this QR code. If you want to get engaged with some of our experts, talk to your account teams, and they'll know how to include us and engage with you folks as well. And we look forward to having those conversations with you, helping you and sort of guiding you along this journey as well.
Excellent. All right, now we are out of time here, so I want to thank all of you that are viewing at home for tuning in, asking excellent questions, and my guest speakers here, Rama and Apurva. I do see that we still have a couple of questions in chat. Please reach out to them on LinkedIn. I know they're active there, or any socials. I'm sure they'd be happy to answer your questions there. You can always reach out to me as well, or drop a comment on this video on YouTube. We can get back to you there as well. If you want to see more videos like this in the future, be sure to subscribe to twitch.tv/AWS or Containers from the Couch on YouTube. Thank you so much for joining us, everyone, and we'll catch you next time.
Thanks, everyone.
Thank you, folks.